for the introduction. And first, I also like to congratulate all the participants to this exciting science fair. You know, you are the choice, right? And you selected group, and this is really a great honor to be here. I guess what I'm going to show is you already have some experience with it when you are doing something, and you are doing the work you assign, and when you find the solution, find the result, that kind of excitement. Okay, and I'm going to tell you my own experience of that. Of course, I have to go back to a little bit background, how I get to this work in the superconductivity. I was not very good in physics when I was a high school student, in fact. Well, that's a certain reason, because I'm from a very local, eastern island, Taiwan island. Not much good, it's a small town. We don't have really very good education system there. We don't have a good teacher. But I was good in chemistry. Right? So I thought I might follow President Wong to do this chemistry. But eventually I found out, the most fundamental thing to understand chemistry actually is from physics. So I really got into really interested in physics later on. So when I entered college, I ended up in Department of Physics. As I mentioned, at the beginning, because my background was not that good, so until the second year of my college, and one day suddenly I opened my mind, I guess, because I was taking one course on relativity, special relativity, theory of relativity, and I was doing very well, and I realized that, okay, you cannot use the conventional way to learn physics, because physics is something really innovative, a lot of, anyway. So I get involved more and more, and really get very in-depth, try to understand what I learned, and that really helped. And then by the time of my senior year, and there was an opportunity that somehow we got involved in the topic of superconductivity. It was not in a course, it's just a sort of a seminar course. Everybody is assigned a topic, and people reading and studying. And I realized there is something called superconductor, and the superconductor is something we never heard and don't really understand, because you want to understand what is the origin or the theory or the fundamental behind superconductivity. You need a very advanced quantum mechanics idea and so on. But anyway, the phenomenon was fascinating, so I started to get into it and try to understand more. And so after I graduated, I went to graduate school, and that was the subject I looked into. Okay? And at that time, that was in the early 70s, people started to think about, because superconductor, if you want to have that be more practical, you need to somehow changing the properties so that the superconducting transition or the phenomenon can occur at a much higher temperature. However, at that time, all the existing material, the highest so-called superconducting transition temperature is around 20 Kelvin, which is extremely low, very difficult to handle, and you need a lot of coolant in a special arrangement to cool it down and so on. So there was a dream to raise the temperature up, okay? And if we can raise it up to certain temperature, such as the liquid nitrogen boiling temperature, which is 77 degrees Kelvin. The reason of nitrogen is that the nitrogen is much easier to handle and cheaper. So if we can do that, then the practical application of superconductor become reliable, can be realized. Okay? So around 70, there are several people, theoretical prediction or some kind of model saying that there's a potential that you can raise it. And that was sort of a dream. Okay? But I was fascinated with that idea and the concept. So that's the subject I took and I studied for my master degree. And after finishing my master, I decided to go to the state for more advanced study, and end up working on PhD and continue on the same subject. And fortunately, we did some very interesting thing in the early 80s. There are a few indications that there might be some phenomenon that can correlate with the idea proposed by theory. Okay? Although it did not go, end up with very high temperature at that time. So when I finished my PhD degree, we were still at very low temperature. The transition temperature was still 23 degrees Kelvin. And that was a little bit disappointing because when I was a student, my advisor always used to tell us, well, we are all dreaming for this high temperature superconductor. If someone in a group, okay, can manage or to find something that about 77 degrees Kelvin, if you find it today, you graduate tomorrow. And your thesis only need one line, okay? Your dissertation, you don't need a whole dissertation, you just need one line. I find this material becomes superconducting at about 77 degrees Kelvin. Okay, so that was the dream to a lot of students. We tried very hard and tried to achieve that, but unfortunately it didn't work. Well, but after that, I still continue to pursue that. In fact, during that period, just like President Wang mentioned, at that time it was a very popular subject because after the first discovery of superconductivity, which was in 1911, and after about 3/4 of a century, the superconducting transition temperature raised from 4 degrees to 20 degrees. Okay, so if you look at that trend, people say, well, you want to get to 77 degrees, then you need 200 years. Okay, so there's no hope for people that time. And so the subject become now the popular in the community. Only very few groups continue to pursue. But fortunately, we stick on, and then I personally also was somewhat lucky to be able to continue to work on that. And in order to achieve the goal, actually, we try all possible ways. One, just share with you, one way of doing that, we even dream to make, try to process the material in space. Okay. That time, I think NASA has several interesting programs using the so-called microgravity environment for material processing. The reason for using microgravity or the low gravity environment then is because without gravity, then you can get rid of this gravity-driven density difference, the segregation because of the density difference between material. So you can use in this low gravity environment to have a better mixing of two different material with different density. Just like you can mix water and oil in space with a very uniform mixture. Okay, the same thing for the material, you can try that. So it was fun, but also it's really interesting. You would try to make a facility and drop from the top 100 meter tall, take a 7-second free fall with that sort of a microgravity environment to do something. Okay, it's kind of crazy, but interesting. Of course, that it didn't get up very nicely. Until around 85, 86, actually there was a couple of efforts to start working on this superoxide material. And by 1986, really, this is chemists really helped. Okay, two scientists from Switzerland, one chemist, one physicist, they worked together. And they reported there was one material that is an oxide, which is a very complicated structure with the 4 elements. It's oxide, which showing that there are possible superconducting transition around 30 Kelvin. the paper was really funny. The title was the possible superconductivity. It was not even say that it's the true phenomenon. But anyway, the paper appeared in the literature, and then we noted and followed it. Okay. And after a couple of weeks, when we started work, actually the whole period was not that take that long to follow what they reproduce what they have, and then we start to look into other possibilities. Now, the chemistry background I had before work. Okay, so I started to use a different idea from the chemistry and do the substitution and so on. So in like January of 1987, we had a very interesting proposal and idea, and then we tried it out. It worked. Okay. What we did was a very simple structure, and more from the geometrical point of view, and then we tried to synthesize a new set of material. And the first material we made, it was after we did the measurement, it showed superconducting with a transition temperature about around 90 Kelvin, which is already way above